Okay, so for problem 3, we're supposed to look at each reaction, indicate whether or not it's a redox reaction, which atom's being oxidized, which is being reduced if it is, and also which is the oxidizing reagent and which is the reducing reagent. So let's look at letter A first. Okay, this is elemental strontium. Pen back on. So it's going to have an oxidation state of 0, elemental oxygen, oxidation state of 0. We have our 2 minus for our oxygen, which is going to give strontium a 2 plus over here, so that it balances out because this molecule should have a net charge of 0. So our oxidation state for strontium is going from 0 to 2 plus. Okay, so it's losing electrons to become more positive. So when you lose electrons, that's being oxidized. And oxygen is going from 0 to 2 minus, so it's becoming more negative. It's gaining electrons, so the oxygen is reduced. And remember, if something is oxidized, then it is doing the reducing, so it's our reducing agent. If something is reduced, then it's doing the oxidizing, so this is our oxidizing agent. So the answer would be yes, this is a redox reaction. Strontium is oxidized and is our reducing agent. Oxygen is reduced and is the oxidizing agent. Okay, look at letter B. Carbon is in its elemental form, so that's going to be a 0. Okay, we have our rule for hydrogen being +1. We have our rule for oxygen being -2. Now, we have to figure out the sulfur. There are 4 oxygens, each one -2. So this is going to be a net of -8. And there's 2 hydrogens, so this is going to be a net of a +2. This whole molecule needs to have no net charge, which means that in order for that to balance out, we would need to get +6 from that sulfur. So we have a total of +8 from the hydrogen and sulfur because we have -8 from the oxygen. So that means that I'm going to put a +6 down here. So the oxidation state for hydrogen is +1 on the reactant side, +6 for sulfur on the reactant side, -2 for oxygen on the reactant side. Okay, so now let's look at the products. So oxygen is -2. There are 2 of them, which makes a total of -4. So that carbon has to be +4 for that to be a neutral compound. Then we have the sulfur with oxygen. So we use our -2 with our oxygen again. There are 2 of them, so it's a -4 again. So our sulfur is going to be +4 as well. Hydrogen is +1 and oxygen is 2 minus, and that works out because there are 2 hydrogens, so that makes it +2, and then the 2 minus, so that balances out to 0. So if you look at it, the hydrogen has a +1 oxidation state in the reactants and products, so it's not changing. The oxygen is -2, which makes sense because that's the rules that we're using sort of to figure out the other ones. It's -2 on both sides. So it's not being oxidized or reduced. So let's take a look at the carbon though. The carbon went from 0 on the reactant side to +4 on the product side. And then our other thing that changed was our sulfur went from +6 on the reactant side to +4 on the product side. So the carbon became more positive, meaning it lost electrons. So remember our Leo lost electrons, oxidized. So our carbon was oxidized. Our sulfur became more negative, was reduced down, so it gained electrons. Gained electrons is reduced, remember, or GR. So The carbon was oxidized. The thing that is oxidized does the reducing, so it's our reducing agent. The sulfur was reduced. The thing that's reduced does the oxidizing, so it's our oxidizing agent. So the answer would be yes, it's the redox reaction. Carbon was oxidized and is a reducing agent. Sulfur was reduced and is an oxidizing agent. All right, I've got the other ones on a separate slide just to give me more room. Okay, so with this next one, then for C, okay, so let's take a look at these. Let's kind of use our rules here. We have +1. I'm going to put the oxidation states on the top, and then if I have to multiply, I'll put that on the bottom. We have -2 for our oxygen. There are 3 of them, so that's giving us a total of -6 from the oxygens. There's only 1 hydrogen, so we have a +1. So we need +5 more. So that nitrogen is going to give us the other +5. So that's going to be its oxidation state. Okay, here for this is an ionic compound. Hydrogen gets its +1. Iodide gets its -1. Okay, and that's just all we're going to do with that. Okay, so with this one, we'll start with our oxygen with the 2-. There's only 1 of them, so the nitrogen's going to have a 2+ to balance that out. Okay, this is iodine in its elemental form, so that's going to be a 0. And then 2- for our oxygen works out with the +1 for our hydrogens because there's 2 hydrogens, so that would be a total of +2 and 2-. That balances out. So our hydrogens didn't change. They're +1 on both sides. Our oxygens didn't change. They're -2 on both sides. But what did change was our nitrogen went from +5 on the reactant side to +2 on the product side. And our iodine went from -1 on the reactant side to 0 on the product side. So our iodine gained electrons, so it was reduced. And no, I'm sorry. Take that back. Our iodine became more positive. It lost electrons. So it was oxidized. And our nitrogen gained electrons, got a lower number, became more negative. So it was reduced. And because the nitrogen was reduced, it is going to be our oxidizing agent. And because the iodine was oxidized, it's going to be our reducing agent. So the answer for C is yes, it's a redox reaction. The nitrogen was reduced, and it's an oxidizing agent. The iodine was oxidized, and it's the reducing agent. That's how you would write that out if you were doing your homework. Okay, the next one, letter D. This is just a ionic compound here with our regular rules, +1 and -1 for the potassium and bromine. If you don't remember those, just look at your periodic table. Okay, remember if you look at the periodic table, magnesium is 2+, and these nitrates remember that nitrate has a negative charge on it, a -1 charge. And there are 2 of them. So overall, this whole thing gives us a -2 charge, which will balance out. Okay, so we need to figure out, though, within this nitrate, what are the oxidative states, so we can figure out the oxidation state on the nitrogen. So with our oxygen, we'll assume 2-, and there are 3 of them. So there's a total of 6- coming from this oxygen. The molecule itself has a minus, needs to have a minus charge. So we don't want to get rid of all of those negatives that are coming from the oxygen. We only want to get rid of 5 of them, so we're left with 1 negative. So if we put a +5 on our nitrogen, and I'm going to put that up here so we have it, that would work out. We'd have +5, and then the -6 from the oxygen would give us a net -1 charge, and that's what we're looking for with that. Okay, the magnesium over here is going to be 2+. The bromine's still going to be -1. Potassium +1. Our oxygens are -2. Okay, there are 3 of them, so this is a total of -6. There should be no net charge on this molecule. So we have a +1 from the potassium, -6 from the oxygen. So we need our nitrogen to be +5. So let's look at everything. Our potassium is +1 here, +1 there, didn't change. Bromine, -1 here, -1 there, didn't change. Magnesium, +2 here, +2 there. Oxygen -2 on both sides. And so nitrogen +5, +5. The oxidative states did not change on any of the atoms. So therefore, the answer is no. This is not a redox reaction. So you don't have to figure out what's oxidized and what's reduced because it's not a redox reaction. So nothing was. So we can move on to letter A, or letter E. Okay, SB, what is that? I don't know. Let me look it up over here on my other one, so I'm not moving the screen around on you guys. Antimony, okay. Or antimony, I'm not sure you should say that. Okay, so that is in its elemental form though, anyway. So that's going to be a 0. All right, we have our oxygens have the 2-. There are 3 of them, so this is going to be a total of -6 on this charge here. Hydrogens are +1, and there's no charge on this molecule as a whole. Okay, so we have -6 from the oxygens, +1 from the hydrogens. So we need another +5 to balance this out. So our nitrogen is going to be +5. Okay, on the product side, now our antimony is in the in a molecule. Okay, so it's over here with oxygen, so we're going to use our oxygen rule with our oxygen being 2-. That makes that 6-. And we need the other 6+ to come from the antimony, and that's going to be and there's 2 of them, so each one will have to have a +3 on it, so we get +6 altogether. So that's going to be its oxidative state. Okay, over here we have the 2- from the oxygen, which makes this +2 for the nitrogen. Excuse me. -2. These are +1, and there's 2 of them, so that balances out. Okay, so our hydrogens +1 on each side. Our oxygens -2 on each side. But let's look at antimony goes from 0 to +3. Excuse me. And our nitrogen goes from +5 on the reactant side to +2. So our antimony is losing electrons, becoming more positive, so it's going to be oxidized. And our nitrogen is gaining electrons and becoming more negative, so it's reduced. And because this is oxidized, it's doing the reducing, so it's the reducing agent, antimony. And nitrogen is reduced, so it's doing the oxidizing, so it's the oxidation or oxidizing agent. So the answer would be yes, it's a redox reaction. Antimony is oxidized and is a reducing agent. Nitrogen is reduced and is the oxidizing agent.